Welcome back to my channel, everyone. Sri Tips here, and this is the final bit of material from the jeweler's floor sweeps. If you remember, we ground this up into a real fine powder in part 1, and then we boiled it hard in nitric acid and diluted the solution. Now we're going to try to extract the gold out of this final beaker. First thing I want to do is reach down in here with a piece of filter paper and get a little on the filter paper. We're going to test for the presence of precious metals in this solution. Nitric will dissolve palladium. We've got a stain showing up there, something in solution. So we're going to have to do some tests here. It's not very much, but it's enough to warrant some further testing to see what it is we have in solution here. Okay, let's draw a little bit of this solution up into a pipette. Put it in this small beaker. We're going to test for the presence of silver. I've got some hydrochloric acid. If there's silver in here, I should form a cloud of silver chloride. And I don't see any clouds forming at all in there. So there's, according to this test, there's no silver in this solution. Okay, let's draw a little bit more of our solution up here. Put it in this beaker. And now what I'm going to do is test for the presence of palladium. What I have here is some dimethylgloxine, commonly referred to as DMG. Got a little bit of it in a squirt bottle here. I'm going to add it to this solution, and let's see if we can form a precipitate here. If we get a precipitate forming, this will indicate the presence of palladium. Let that set for a minute and come back and look at it. Alright, I really can't see a reaction in there. I've got another little jar here of DMG dissolved in water. What we're going to do is get a little bit larger quantity of it and add it to this sample and see if we can get some precipitate to form. I've got a small bottle of ferrous sulfate here. What I'm going to do is get some of this material, put it in a spot plate down here, and then we're going to add some of our solution to it. If we have gold in solution, then we'll see a cloud, a brown cloud, form around this cavity here. When I put the solution in, if we've got gold, we'll see a brown cloud. Here we go. Let's see what we got. Oh yeah, we got gold in solution. We got gold in solution from the nitric acid boil of this finely divided material. According to this test, I've got no silver in there, and we've got no palladium in there. So it's gold that's been dissolved with a hot dilute nitric acid boil in our finely divided material here in this beaker. I've got my vacuum bottle hooked up to a vacuum. Now we're going to draw this gold bearing solution out of this beaker with a vacuum bottle. Here we go. This is so that we don't disturb the sediment down at the bottom of this beaker. It's already all settled out, nice and clear. So we don't want to get all that sediment mixed in with it. Okay, now I've changed the tip out. I've got a very fine tip here, and I can stick this in here and draw this liquid up out of here without disturbing the sediment. It's down in our jar here. Alright, we've got the solution drawn off of our solids. I've got another filter rig set up here with a specially prepared filter paper. And what we'll do now is we're going to filter the liquid that we just pulled off of here out of this container. Alright, let's wet the filter up here. And the amount of gold in here is probably stock pot worthy. Well, we're going to go ahead and try to do a recovery here of anything that we can get out of this solution. You'll notice that the clear settled solution that we draw off pulls through the filter very quickly. Now that we've got all the clear liquid pulled through the filter, we're going to capture this sediment in the filter now. Hopefully it won't pull through. It's a very fine sediment, so some of it's probably going to pull through here. Now we're getting a good separation there. Alright, we're getting all our solids into this filter. Boom. Alright, that filtering is complete. Now what I'm going to do is I'm going to transfer the solids out of this funnel and into this beaker. If I can do it without making a mess here. There we go. I'm adding some hydrochloric acid. About, I'll make it about 300 milliliters or so. Alright, as usual, I'm going to add a few drops of sulfuric acid to precipitate out any lead that may be present. Now I'm going to add a splash of concentrated nitric acid to form aqua regia in our beaker. That was probably about 25 or 30 milliliters. And now we'll stick this up on the heat and let this react. While we're waiting for this reaction, what I'll do is I'm going to add our gold-bearing solution to this 2-liter beaker right here. And now what we'll do, put some low heat. I'm going to set this up on a burner and let this slowly evaporate to try to concentrate that solution. This has been on boiling now for about 4 hours. I'm going to pull this down. I'm going to add some distilled water. Alright, I'm going to pull the other solution down. This is a fail here. It didn't really evaporate much. I'm going to reach down in here and get a stannous test on this one here. I'm not expecting a whole lot of gold from this batch. As you can see, we've got a stain developing there. This is the stain from this jug. It looks like we got less than 1 gram per liter for both of these solutions. This is a 1 gram per liter known quantity of gold test solution that I prepared. And if you put some stannous on here, you'll see that we get a nice dark stain, much darker than this one. So this is, I'm going to call these less than 1 gram per liter. I'm going to set this up out of the way. Set up a filter rig here. And we'll filter this solution now. Yeah, I think this last batch with the finely divided material will end up having the least amount of gold that we can recover from it. Got all the solution pulled through now. What we're going to do is transfer the liquid into a clean beaker. Let's get this guy out of the way. Let's get this solution down here. We're going to put some stump out in both of these containers. And then we're going to let them settle and see how much gold we get out of this. It's not going to be much. Like I said, the tests indicate less than 1 gram per liter. Stir them up a little bit, and we'll just let these react and come back in a little while and check on them. I've allowed the solutions to settle overnight. There's a little bit of metallic gold floating on the top of each one of these, but if you look down underneath down here, you'll be able to see that we've got just a light dusting of gold on the bottom there. I think most of that is probably undissolved sodium metabisulfite. This one over here clearly has a coating of gold on the bottom of the beaker, and if you look at it, it's got an unusual formation inside there. It's like some suspended gold particles in the liquid. That looks pretty neat. So now what we're going to do is going to give these a quick test with stannous chloride. I'll get a little of the solution on this filter paper, and then we're going to hit it with some stannous chloride, and you'll see there's absolutely zero reaction. Same thing for this beaker. Make sure we got all the gold precipitated out. And there you can see it. I've got zero reaction. Here's both tests after I allowed them to set for a few minutes. And they both got just a slight tint of orange to them, which tells me that there's probably going to be slight traces of platinum group metals in both solutions. So we'll add both of these solutions, the waste solutions, to my stock pot. I've got a filter rig here with one of my specially prepared filter papers. So now what we'll do is set these up out of the way, and we'll set this filter rig up and filter what little gold we got out of those solutions. Here you can see the slight amount of gold that we're going to get out of this. It's very small. Just a light dusting of brown powder on the bottom of the beaker. This beaker has a decent amount of gold that precipitated out. Let's get that down in our filter. Here's a look at the gold that we have down in our filter. Rinse it off with a little bit of hydrochloric acid. Rinse it with a little distilled water. Alright, now let's get our gold that we've got filtered out down into a smaller beaker here. There it is. It's not much. Pull the filter out now and add it to this small beaker. I'm going to add a little bit of hydrochloric acid, a little sulfuric acid. I'm going to add a few milliliters of nitric acid, about 2 milliliters or so. Now we'll cover this up, put it up on some heat, and let it dissolve a second time. That took less than 5 minutes. Pull it down off the heat and let it cool down. I'm going to add an ice cube here to help it cool off. Reach in here and test it with stannous. Make sure we got some gold in solution. There you can see we got a little brown stain. Got it all pulled through the filter now. Let's transfer it to a clean beaker. It's not going to be much gold in there at all. Now I'm going to add some stump out, which is sodium metabisulfite. Someone asked earlier in the video, or in a previous video, why doesn't the gold come out of solution quickly and spectacularly like we've seen it in the past? And the answer is the concentration of gold in this solution is real low, and that will affect how quickly the precipitation happens. When you've got a low concentration of gold like this, the precipitation takes a long time. It's much more boring. When we've got a high concentration of gold in solution, then it's a spectacular cloud of brown that bursts out of the solution. So the concentration of the gold will determine how fast it precipitates. This is about 20 minutes worth of footage, speeded up with time lapse. We've got a filter here. Let's get this set up. I'm going to wet it so it stays in place. Here's our gold. You can see it settled out a little bit. And what we'll do is just filter the gold out of the solution now through this filter. Wow, look what's in our filter here. It's mostly undissolved sodium metabisulfite. Good Lord. Very little gold at all to account for this part 4 refining, but we're going to push through and get our gold here. Here's a look at the gold. Not very much, almost nothing. I've got some hot distilled water in this beaker. I'm going to pour it in here and try to dissolve off any remaining sodium metabisulfite that might be in there. There's that small amount of gold we got down in the bottom of the filter. So now let's take the filter with the gold in it and transfer it into a small melt dish. It's got a little bit of borax in it, that's okay. And let's move this over to the melt table now. See if we can melt this up into a little bead. Alright, I like the idea of burning the paper with alcohol. It burns the ash and has less of a tendency to blow out of there when we put the torch on it. So I'm just going to go ahead and burn the filter paper with some alcohol.
I'd like to give a little shout out to Sarah Jean. She is the viewer who suggested burning the filter paper with alcohol. I think it's a very beneficial suggestion, and I'll probably use it from here on out.
Here we go. We're going to go ahead and hit it with the torch now. I do like the idea of burning it up with the alcohol ahead of time. As before, what I'll do is try to heat the dish up, and there's going to be little balls of gold in the bottom down there that become molten, and then I'll manipulate them with a pair of pliers to try to get the gold to coalesce into a single mass so we can get it out of the melt dish there. If you look down in there, the amount of gold that's in there is so small I can't even get it to come together and make a single mass. I'm going to try adding some borax, see if I can get that stuff to flow together into a single mass. We've got about 5 or 6 small BBs down in there, and I just can't get them to flow together so we can get it out of there and show a yield for this batch. The amount is so small. This is a good example of why you don't want to try to chase after real small dots of gold. It's ends up being an exercise in futility. Yeah, I can't even get those pieces of gold to flow together. Alright, sometimes you can use the oxyacetylene flame to kind of push those pieces of gold into a little pool, and they'll come together and join into one single mass. Let's see what we can do here. Alright, I was able to get those things to come together into a single mass. It's a very small bead of gold in there now. Add a little bit of flux to it, some borax. Now let's see if we can get it out of there before it freezes in the melt dish. Boom, there we go. It's a little bitty BB of pure gold. Let's reach down in here and get our little BB of gold. There it is. It's not going to be very high purity. Tiny little BB of pure gold. I've got a little beaker here. It's got some dilute sulfuric acid. I'm going to drop our little BB of gold in here. We'll heat this up and try to dissolve that flux off of the gold. Alright, we've got all the flux off of there now. Let's take it over here to our sink here and get our little bead of pure gold. Alright, we've got all the acid rinsed off of here. Here is our little BB of pure gold. Very tiny. But we got it. Here's our BB of pure gold. Let's get it on the scale here. 0.2 grams of pure gold from the final beaker of the low-grade floor sweeps from the jeweler's shop. Alright, this will conclude the series. Thanks for watching.